Okay, this looking at just some polynomial stuff. Some of this you already know. So, for example, ax to the n. A is the coefficient. Of the n, and n is the degree of the polynomial. So if you have a polynomial with a number of terms, say for example x squared plus 2x plus 5, and then you look at the highest power. In this case the highest power is that one there. So this one has degree 2. Also has something on the end here, and so it has a constant term. In this case 5. Okay, so like in general then, kn(x) to the n plus kn minus 1 x to the n minus 1 all the way down to k1x plus k0 would be some polynomial where just all these k bits are coefficients, and of course the k0 on the end is the constant term. Now the thing is that n has to be an element of the natural numbers, so that means that a polynomial can't have a negative power. So let's have a look. So something like this, for example, x cubed plus 2x squared plus 1 is a polynomial. Something like this which we could rewrite as x plus x to the minus 1 is not a polynomial, and it's not a polynomial because of that negative power there. Alright, right, there's some other things we can do with polynomials. We can equate them, for example. So let's have a look at an example. Okay, so here's an example. So we've got 5x cubed plus 2x squared minus 7x plus 1 equals 2a plus bx cubed minus ax squared minus b takes c in brackets x plus 1. So we need to equate our coefficients basically of each, and so we're looking at those two things being equal, coefficients of the x squared terms being equal, coefficient of the x terms being equal. So when we do that, you can find that 2a plus b is equal to 5. You then find that negative a is equal to 2. And you also find that negative b takes c is equal to negative 7. Okay, so from that, looking at that second one, it's from that we then know that a is negative 2. Okay, so if we now know that a is negative 2, we can go and do some substituting. So this the first one So if you sub in 1, you find that negative 4 plus b equals 5, which then leads to b equaling 9. If we then go and substitute a and b into the third one, you find that c will be equal to 2. Then I'll leave you to do all that, because I'm sure that you're able to. Okay, so that's a simple one. Let's look at a couple more examples. Okay, so here we go. We've got m to the 4 plus 4 equals m squared plus am plus 2, m squared plus bm plus 2. And we're going to find a and b. So essentially we've got to expand the right hand side first of all. Alright, so we need it in a form that we can equate. Now when we do that, I won't go through all the steps, we find then that it equals m to the 4 plus b plus a m cubed plus 4 plus ab m squared plus 2 plus 2 a plus 2b m plus 4. Squeezing it in on the end. Alright, so now we've got quite a few things. The M4 we've got here and here, so that's the same. The 4 we've got there and there, so that's the same. The only bits that are not the same are these bits in the middle here. So the one on the right hand side doesn't have an m cubed term, an m squared term or an m term. So what that means is that we can get 3 equations, and b plus a equals 0. Then 4 plus ab is got to equal 0. And 2a plus 2b has got to equal 0. Okay, so we've got that now. The first and the third are just exactly the same. So we've got our two terms here. And so from equation 1, we can find that a is negative of b. Okay, and then we can substitute that into number 2. And so when we do that, you get 4 plus negative b times b equals 0. And when we then solve that, we get that b squared equals 4. So b equals plus or minus 2. So from that then, and looking at the fact that b is negative a from when we rearrange number 1, so that would mean that when b is positive 2, a is the negative of b, so a is negative 1, and b is positive 2. Negative 1, where did I get that from? Negative 2, I should say. And a is 2 when b is negative 2, because a is the negative of b. Okay, so there's that one. And let's look at one. Okay, so this one, x minus 4 is a factor of x cubed minus 6x squared, not 6x to the 7, plus 2x plus 24. Okay, so when what that means is that x cubed minus 6x squared plus 2x plus 24 is equal to x minus 4 times by something else. Which would be an ax squared plus bx plus c. It has to be ax squared because we need to get that cube term. Alright, so there's a couple of different ways you can go about doing this. Okay, you can span the right hand side, equate terms, coefficients, or you can do everybody's favourite division. Because if you divide x take 4 into it, what's left will be polynomial after. So to get x cubed you need to multiply x by x squared. So we again got x cubed minus 4x squared. And we've got to take that away. So minus 2x squared plus 2x, bring that down. Minus 2x plus 8x. Take that away. Minus 6x there plus 24. And minus 6. So minus 6x plus 24. Take that away. We end up with 0. Alright, so if you're not sure about that division, give me a yell and I'll come and explain further to you. But the polynomial we were after is that one there, x squared minus 2x take 6 as being the other factor. Alright, now of course you can use your calculators, simultaneous equation solver, your factorising functions in your CAS calculator to help you in some of these things. Okay, so this is exercise set number 7, 8A.